We are familiar with the observable universe. We can see the stars, and we can see black holes using a global network of 8 radio telescopes and 5 petabytes of data. We can see quasars from the early universe. But there's something that we can't see, and that's dark matter. Now, we know that dark matter makes up 27% of the universe. The things that we can see, such as the stars, the black holes, chalk, you, only makes up 5% of the universe. So that's a lot of things that we don't know what it is. All we really know about dark matter is what it's not. So you've probably seen in the news that we have imaged our first black hole. And black holes were originally a candidate for dark matter because, well, as their name suggests, they're very, very dark because light can't escape from them. So they can be a little hard to see. However, the reason why black holes have that lit up ring around them is because of an effect called gravitational lensing, where they're so powerful, their gravitational pull is so strong that it bends the light around them. However, this means that if they did account for dark matter, we would have been able to see those lensing effects, and we just don't see enough of that to account for 27% of dark matter. So what about antimatter? Maybe they're just a bunch of antineutrons and protons and electrons on the outskirts of the galaxy, and that's what dark matter is. However, antimatter likes to annihilate with normal matter, which will send off an array of gamma radiation. However, we have not detected that gamma radiation to account for that either. Okay, so what if dark matter is just normal matter or baryonic matter, such as maybe protons, electrons, brown dwarfs, which are failed stars, or maybe just a bunch of aliens named Bob? Well, the problem with that is we know dark matter doesn't interact with normal matter, so it can't be baryonic matter, or else we'll be able to detect it. And unfortunately, we haven't detected enough to account for that either. Okay, so if we can't detect dark matter, if it doesn't seem to interact with normal matter, then why should it even exist? What's the point of it? How do we know it exists? It all goes back to galaxies and our good old friend, gravity. So, with galaxies, you have a bunch of stars and a bunch of gas that's rotating around the galaxy. And that means you also have stars that are on the outskirts of the galaxy as well. However, these stars are moving at much higher velocities than they should. At the velocities that they're going at, they should be kicked out of the galaxy. But they're still there, so that means that there's something that's holding them together, that's keeping them there. And that's where dark matter comes in. We know that there's some sort of matter, some sort of substance, or something that's keeping them there. And we even see this effect in other galaxies as well, so it's not just us. This is a whole phenomenon across the universe. So then, what is dark matter? Well, there are a couple theories. There's a type of particle called WIMPs, or weakly interacting massive particles. These are particles that are theorized to exist that interact very weakly, if at all, with normal matter, which is why they would be so hard to detect. They're also electromagnetically neutral, which means they would have no charge. However, we haven't detected those. There's also another type of object called MACHOs, or massive astrophysical compact halo objects, which is kind of like WIMPs in that they are very hard to detect. And so that's another possible theory. And there's also the possibility, although very, very, very unlikely, that we have a fundamental misunderstanding about gravity and general relativity. So as it stands, we still don't know exactly what dark matter is, but I'm hopeful that in the future we will figure it out.